sequence that is graded 9 with a maximum of 9, and the last choice, if you want 10, would be to represent the parsing tree using in a table-like format using father-sibling relations. We will discuss at the due time when we will have to implement the class corresponding to the parser output. So this is your choice. The representation you, sorry, I should share in order to for you to see what I.
Is it better to use any of the representations over another one?
No, because they are completely equivalent. So using any of those, you can obtain. We could obtain the other two, but they are graded differently based on the effort you should that is involved. Basically, the first one is, as I've said, given almost directly as an output of the algorithm, and the other two require some effort. So passing from the first to the second means building that series of derivations starting from the starting symbol, and the last one is the most complex. You need to build that table, but other than that, they are completely equivalent. So the mark that you achieve is what drives your goal. Okay, today is the first lab, so you should deliver part 1, which consists in the grammar class, the one which you need in order to store the grammar, on which you will apply the parsing algorithm, and you should check, or you should test that loading both a simple grammar as ones from the lecture or from the seminar, and the grammar corresponding to the syntactical rules from lab 1B. All right, so you should take those syntactical rules. You know by now, because you've worked with grammars, that those rules actually match the productions of a grammar in which the starting symbol, the non-terminals correspond to the syntactical structures, are the items on the left of each rule. So program, declaration list, statement, and so on. And the terminals are the tokens, the lexical tokens from those 5 categories: reserved words, operators, identifiers, and constants, those which are between quotes, plus the identifiers and constants which are returned based on which are returned by the scanner. Okay, so you should first test on the simple grammar, and then on the grammar corresponding to your language. If you work in pair, then you can choose any of the 2 grammars. I've told you in the second lab that the best choice would be to represent the syntax using standard BNF, and that's why, because grammars match standard BNF. So if you've represented using eBNF, your first step should be to transform to standard BNF, and then then write it into a file from which you will load it in order to test your grammar. Okay. Be careful when you define the data structure for the grammar that the requirements include checking whether the grammar is a context-free grammar or not. Do you remember what a context-free grammar is? You should have in the left-hand side of any production exactly one non-terminal, right? So you should allow reading grammars which are not context-free in order for the context-free grammar check to be meaningful. And you should also take into account the fact that when you apply a parsing algorithm, you will need to have those productions numbered. More than that, for the recursive descendant, you need to have the productions of each non-terminal numbered separately. Okay, so that's another issue to be taken into account, and the fact that even though the grammars, simple grammars from the lecture or from the seminar, use terminals and non-terminals of a single character, the grammar corresponding to your syntax has terminals, non-terminals, strings. The program is a non-terminal. Begin, for instance, is terminal, and so on. So you should pay attention to the way you define your data structure in order to avoid rework when you have to test with grammar corresponding to your syntax. Okay, take the general case into account. And that's about everything. So today is the grammar class. You should test at least for a simple grammar, then put the sources on Git, any of the 2 repositories if you are working in pairs, and then upload the link for the model assignment. And until next week, you should test on the grammar corresponding to your syntax also, and upload the documentation of the grammar class. And next week we will continue with the second part, the second subtask, which concerns implementing the functions corresponding to each parser. So that those would be the possible transition types in case of the recursive descendant. For LL1, first and follow, and for LR0, you see this week closure, go to, and canonical collection. So those would be the next tasks. So I suggest by next week, please read the lecture, the seminar, in order to be able to ask me and to discuss the algorithm or the functions to avoid mistakes in your implementations and to work efficiently during the lab. Okay, so much for today. I would so please write me in chat the components of each pair in order to be able to create your channels, and you will discuss on those channels. So if you work in pair, you'll have to define one grammar, so one grammar class per pair. But be careful that even though it is a team assignment, marks will be per team member, not per project or per assignment. Okay, so the marks will, the grades will reflect the contribution, the individual contribution of each team member with respect to the delivered issues. Okay, so you should try to split your work in a balanced way in order for the evaluation to be fair. Okay, if you work, I don't know, if you do pair programming, for instance, because this is one way of dealing with this issue, then it is assumed that each one of you knows everything from the written code. If you don't want to do pair programming, then you should split somehow and interact through interfaces, you know, in order to accomplish the assignment. Okay, so I'm waiting for pairs or teams in the chat. And for questions, if you have any. We'll have 4 labs. This one will concern grammar implementation. The next one will cover the functions required by the parser. Then you will have to implement the tables if tables are needed for the analysis and the algorithm in the next lab. And in the end, you have to integrate tests on both the simple grammar and on the grammar corresponding to your language, and do some code review. That's the structure, general structure of the 4 labs. Okay, Denisa and Flavio, you have LL1, and I will create a channel. Okay, channel created. I will also add the parsing method, not to forget it. You can go there and start on it and implement the grammar. Then we have Bianca and Bogdan, LR0. Okay, your channel is